It's all happening in real time. Anyways, all right, cool. Woo! That was a terrible joke. I'm really excited because I've been messing around with building mobile applications as a real job for over 8 years. And I never thought in my mind that with just 3 or 4 lines of code, I could create instantly connected real-time applications. And I never thought this because I used to have to write all the TCP and UDP code all myself, multicasting myself by hand, and it was terrible. Has anyone ever had to do that? Yeah, and you're all like, yeah, I never want to do that again, basically. Sometimes you got to get down to it, but when we think about building real-time applications, they really span all the different devices out there, and that's where SignalR can come in. It's literally in the title of this talk. So what I want to focus on is how SignalR as a service, what it offers, what it does, what it brings to mobile applications, but also to your web apps or any other type of application, and just how awesome our cross-platform .NET story is. So today, I'm going to show you everything there needs to be known, humanly possible, about building real-time apps with Xamarin and SignalR on conference Wi-Fi. That's very important. Everything that you see here, conference Wi-Fi. In fact, we were working on the roulette application, and I needed to push an update. Did it over conference Wi-Fi thanks to Wi-Fi debugging. It was amazing. Really cool. Yeah. So we're here to talk about SignalR. And SignalR is a service from Microsoft that enables real-time communication across different types of application platforms that you may be building for. Now, SignalR has been around for a while, but there's kind of a new flavor of SignalR with ASP.NET Core coming out, and it's sort of been re-architected from the ground up. But let's first talk about what real-time applications are and why they're so important nowadays. Well, for me, it's really important because I'm traveling all the time, we're on the go all the time, we need information immediately, and we want them on all of our different devices. So no matter if we're on the go with our tablets and our PCs, or we're sitting at home gaming, or we just have everything around us as we're constantly communicating, having that instant notification is really important. It's really insightful to me when I'm inside of Teams or inside of Slack and I see someone typing and I know that they're following up with me. Just as equally important when they stop typing and didn't send the message. And why didn't they send the message? And that's something that's also very important, because nowadays, not only is like the startup time of our application important, but it's the things and the interactions inside of our applications that are ever so important. So it's fun to have some nice animations, but I wanted to walk through a few scenarios that you may be thinking about for real time and what you can actually do with it. So for instance, you might want to build like a chat application. Here, for instance, this is using SignalR, where I'm authenticating with Twitter. And as I start typing, it updates on the other side, has some information about me in general, and I can type back and forth into the browser, and I can get some information about me here. You could do some other things, such as do private messages that come across, for instance, and send some additional information across the wire. Perhaps you're doing real-time collaboration on a whiteboard scenario, where on one side of the screen, you're actually coming in and you're drawing, and on the other side, it updates immediately. This could be any application, whether it's a mobile device, a game, or a web browser. Some other scenarios that are oh so important: when I sent my partner the FlightAware map of where I was going in, was getting real-time information of where my airplane was on her map on her phone. It could just update. She could see immediately where I'm at because that information is publicly available. Now, inside of mobile apps, though, there's something that is quite intriguing that we could do besides just saying the entire app is built on a serverless process. What if we could take a single piece of our functionality and really fine-tune it to give instant gratification and updates to our app? So here, for instance, on the left-hand side, I have a Cosmos DB entry. And on the right-hand side, as soon as I update it, it updates instantaneously inside the browser or inside of a mobile application. This can extend to absolutely anywhere, though. Maybe you're running a Raspberry Pi or a NetDuino, because you can run real-time applications directly on those devices communicating to anything. So you can imagine how imperative that would be in an IoT solution. So from start to finish already, we've seen web scenarios, mobile scenarios, IoT scenarios, and there's a lot more too that we'll go through. Now, the awesome part about SignalR is what SignalR does is it abstracts the common patterns that need to take place for real-time communication. And the default that it uses is WebSockets. Now, WebSockets are a really great technology. They've been around for a while, and they're tried and true. However, not all servers and not all devices may handle WebSockets gracefully. Some older versions of Android, for instance, or maybe older browsers. So what's great about SignalR is automatically SignalR will figure out if the device can handle WebSockets, use that, else fall back automatically to server-sent events or long polling. And you don't have to think about it at all. It just happens. So when we think about the billions of different devices in the world, there are some use cases that SignalR can handle. So the first is that all of these here are just readily available, and perhaps I want to just broadcast a message to every single device possibly connected right now. We all got Amber Alerts earlier, and that's a use case for real-time notifications along with some of the other scenarios that I did where I'm broadcasting a message out to as many people as humanly possible that are connected to the service at that time. So that's the first use case that I want to talk about, and here's sort of how it works. The basis of a SignalR is that there's a hub process, and this lives somewhere, usually on a server. We'll talk about the different scenarios in which you can host SignalR. And then you have your hub, which is the base process, and what it does is it handles the connection between the different devices. So once a device connects to it, the hub simply says, hey, you're connected, and it'll send you an event. What's great from this aspect is that it automatically handles connection management. It'll handle all of the device registration. It'll send all of these connected clients, those messages simultaneously. And we can even go down more finite into groups or specific clients, which I'll go through. But more importantly, if we're sending tens of thousands of messages, SignalR will scale gracefully with increase of traffic. So now you kind of know what SignalR does, and the very easiest concept of what it can do, how do we get it into our applications? Well, remember there's the hub client, which is what all of the, I'll say the hub device that is connecting to all the clients. And that is going to be written in C# with ASP.NET as the SignalR hub, or this magical SignalR thing that I'll get to later that's part of Azure. And then all of your clients can connect via using JavaScript, TypeScript, Java, or of course, .NET and .NET Standard across all of your .NET applications, including your Xamarin apps. So what I want to first do is walk through the easiest broadcast scenario that we can do for SignalR. And every single one of my demos are available on GitHub today. So I'm going to switch over to my Mac, and that way the AV guy knows, boom, oh, look at that. That's graceful. All right, so I'm going to switch over to my Mac really quick and plug in some power into here. There we go. And let's see if it pops up. And everything will scale all crazy. Oh my goodness. All right. Oh, look good. Okay. So what I have over here is everyone's favorite Xamarin application ever. It's the default master detail view. But it gets the point across that what we have here is just a Xamarin app, an Android and iOS app. And then what I've done is inside of our default project template, we have add an ASP.NET Core backend. So that's what I've done. Now, normally when you go and run this template, you have to go and your mobile apps connect to it either locally or you push that up to Azure or some other web backend. And then you're sort of pulling to refresh. You've submitted it to your ASP.NET Core. It inserts it into your database. You have to pull again, you know. But what I thought is what if every time I added a new record into my item repository that I notified all of my devices, no matter where I do it, whether I do it on the web or if I do it from my mobile apps. Now the cool part here is that everything on the ASP.NET side is built directly into ASP.NET Core. There's nothing else you need to add for SignalR. It's built in. So how we enable that is in our startup code. How many of you have done ASP.NET, ASP.NET Core development? A few of you? OK, perfect. So there's this startup configuration that handles all of the dependency injection and IOC shenanigans. And this is sort of the startup, if you will, inside your app. So it says I'm going to add MVC. I have some permissions here. I have some Swagger definitions. And then I say add SignalR. And that's going to tell our services in ASP.NET that I want to use SignalR service. And then I'm going to configure a hub. You can have multiple hubs that do multiple things. Here, I'm going to say SignalR, map a hub of messages hub, which I'll talk about here in a second, to /hubs/messages. So I could have hubs, /chats, /messages, /updates, /airflight, /blah, blah, blah, /how many cups of coffee have I drank today? Not enough. And you can have as many of these as you want. So if we look at what this message hub is a hub. Ba-da-da. This is the most easiest hub. It doesn't do anything. It's just a mapping for where we can make calls on. So normally what you'd put inside this hub, and I'll show a more complex sample in a bit, is all of the logic for updating, sending the messages, receiving the messages, all that stuff. But I figure what I'll do in this case is inside of our item controller, whenever I create an item, I want to then send something from my hub. So what we can do is here, I'm passing in my item repository, and I can also put in iHub context. So I can get access to that hub in my app. And that's what it is right here. So here, I have normal gets and puts and posts and all that jazz. And what I'm going to do is come in, and I'm going to take the item that's passed in and created and add it into my backend. I'm going to serialize it as JSON, and I want to send that to all of my connected clients. So here, when I type in await hub.clients, I can get different access to clients or groups connected. So those are sort of the things that I have. When I go into .clients, we can see I have .all, for instance, so I can send it to everyone. And then I'm just sending a JSON package, just as almost if I made an HTTP request. I say, to all my hub clients, send this JSON across. That's it. And that's my backend, literally like 4 lines of code. And now Azure, or SignalR is configured in my backend, and I'm sending the message with this key of new item. So everything in SignalR is key value pair. And you can have multiple values that you send across, but you're always sending a key with a bunch of data back and forth. So let's look at the Xamarin app here. The Xamarin app is pretty standard, but what I've done is I've added the ASP.NET Core SignalR client. It's a really funky name because it says ASP.NET Core, but I'm adding it to my Xamarin app, and that's kind of weird. But it makes sense if you think about it real hard for about 4 months. Because I think I just got it on stage. It is the client SDK for SignalR, which most likely lives inside of ASP.NET Core. Sometimes. So just bear with the naming. It's a NuGet package. Who cares? So here's what we're going to do. What I want to do is every time I get that new item message, I want to add it to my list. So to configure SignalR, it's crazy easy. Remember when I had a hub before of my messages hub? Well, now I have a hub connection for my mobile app client. I'm going to make a connection to that hub. And what I do here is come down here and I create a hub connection, which is just a URL like we've always used. It's a place on the internet where that hub lives. Now in this instance, this is going to create a connection builder. I give it a URL and I build it. And here, when we go to declaration, we can see what I'm doing down here is I'm passing in for Android the specific local IP address or localhost if it's on iOS. So this is a special IP for the Android emulator. So that way I can talk here. If I publish this to Azure, I would just put in my URL. So then, once we have that set up, we have these really cool methods that will allow us to subscribe to events. If you were just in the reactive programming, it kind of is like that. It says, hey, connection on whatever you expect. It could be an item. It could be a string. It could be multiple items. It's T-based, so you could expect a string, a Boolean, an item, for instance, back. And I'm expecting it to be new item, and then it's going to give me a new item in string, so it's templatized here. Now, since SignalR is coming back on who knows what thread, I mean, it's some magical thing that's listening, I want to add a new item into my list. So of course, I'm going to use Xamarin Essentials, and on my main thread, make sure that I invoke this on my main thread so I don't break my application. So what I do is I take that string, I deserialize that item, and I make sure that the item ID doesn't exist. Because if I push it from one mobile app that's already added into the list, I don't want to add it to itself, right? So only if I don't already have this item in my list, insert it. That's the only logic I need to put in to start listening for events. Now, I need to start the connection, though. Now, this is demoware, not best practice. But what I'm doing here is the very first time I load my items, I'm doing a very simple call here. Look at this terrible code. If I've connected once ever, then don't worry. If I've never connected, we'll say start asynchronous to that connection, and then I'll say connected true. And then I'm just going to pop up a dialog box. So literally, there's start async, stop async, that's it. Whenever I have my builder, build my connection, listen to stuff, start stuff. That's it. So now what I'm going to do is I'm going to first start up my backend. So here I have the terminal open right here. There we go. I'm going to say .NET run. And I'm going to run my ASP.NET Core application in my backend. So this will say run, and it should build up. There we go. Warnings, whatever. All right, so it's on localhost. Let's open up a browser. Come on, MacBook adorable. There's a reason that they stopped making you. All right, so I'm going to say localhost 5000. Boop, boop, boop. And I have the Swagger definition. So inside of here, I can try out my API. And when I execute, I'm going to get some items back, so some 3 default items, which is cool. So now what I'm going to do is run my mobile apps. So I'm going to hit debug here. All my code is in place. I'm going to compile out my project, and in Visual Studio for Mac, I have it multi-deploy. So this will deploy to my iOS and Android emulator at the same time, and they're going to be listening on the same address. Cool. Cool. So this one's connected to SignalR. It's connected. I have those 3 items back. Android's still booting up. Give it a second. There we go. It's going to connect up, and it's connected to SignalR. Boop. Gets the items back. Perfect. So now what I can do is come over here, and I'm going to do a post. Remember, whenever I post a new item, it's going to send that message to SignalR, from SignalR to the clients. So we'll say try it out. And here, it's just the default of string. Let me go and move these over so we can see them really nice. And I'm going to say execute. And they just update automatically right inside there. That fast. And you can see I added a random number, so you can see just how fast it's coming across SignalR with literally no code to get that update automatically. But what's great here is that if I hit add, for instance, on one of the devices, and I give it an item name, and I'll say new. Oh, my emulator's great. There we go. Hit save. Immediately, right over there. Which is pretty cool. Now, it didn't add it into this list because I insert that at the very, very bottom on Android, because that's how the default one does it. And I insert it from SignalR on the top. And you can see how fast. I didn't have to long pull. I didn't have to query the server. It's happening in real time with literally like 10 lines of code. Awesome. So when you think about real time, think about that. I don't need to have a real-time application that the entire thing needs real time. Think about 1 or 2 use cases where maybe this data could be a lot better if it was updating live, and how I could integrate that into my apps. Let's head back over to my PC as I disconnect my Mac. Oh, no. Oh, there we go. He's on it. He's awesome. Cool. All right. Beautiful. So that's like the easiest use case that I could possibly sort of think about for a V1, just showing how easy and simple it is to get started. And that same exact code, is it coming across? Not yet? All right, let me back out of PowerPoint, back in. Just in case. Just how easy it is to do something such as just sending a notification across. It's easy to do. If you already have an ASP.NET website, boom, you're good to go. Now, if you don't have an ASP.NET website, I'm going to show you how you can easily integrate this into other services. So we talked about this broadcast, all these devices, broadcasting them out to everything humanly possible, whether it's a mobile device or not. But we can go a little bit granular. For instance, maybe I only want to send to users. SignalR can handle group-based notifications. So here I could say only send it to anyone registered in the Seattle group, for instance. Or maybe only people on an iOS device or an Android device, which is nice. Or you can target even more fine-grained and say only send a message to a specific user. Every single connection to SignalR generates a unique client ID for them automatically that's registered that you have access to. So you can send that information back and forth. So if we look at how we can make something even more complex, different scenarios here, we can think about it in not just a broadcast, we could even do broadcasting from device. Because while the hub itself can send messages, it can also receive messages in real time. This is also unique. So here we can send a message from a laptop or a mobile phone, and then we can send that message back out. This would be a really great use case for a chat application because you can't do real time without a chat application. So I built a little chat application to kind of show how we can not only broadcast from a device to other devices, but also do them in a group. So here's what we're going to do. We're going to head over to Visual Studio. And here is my app inside of our previewer, our updated previewer with design time data. So here, for instance, I have the connected clients up top. So whoever's connected, I have some information there. And what we can see up top is that I have a collection view, and I'm using an array of users. So I'm not specifying a string. I'm actually using my real data model here to pipe in some design time data into here. And then I'm using frames, frames for day, just every day a frame, basically. If we need a circle, just use a frame, frames all day. I have another collection view down here, and I'm using a trick by one of our MVPs. What is his name? It's called the 180 by 180 by 180 trick. It's amazing. If you want things to rotate from the bottom, you take it, you rotate it, and then you flip it again. It's bananas. So I have another collection view with yet another data binding here for design time with some messages. And then I always like to use the previewer and put a little spinner up here. So how I get that running is I use design time to show is running and is visible. So this is kind of my layout that I'm going to use here. So that's the application. And what this is going to do is multiple things. It's going to show me a list of rooms that are the groups that I can subscribe to. And then it will enable me to subscribe to a group and send chat messages to that group. So this means that our backend hub needs to be a little bit smarter than that blank empty shell. So I'm going to go into the startup code. And what we'll see is we just have an ASP.NET Core application. I've added SignalR here. Let's make this bigger again, because that's about how big I code at home. And then down here, I say add using SignalR and my route. And before I had /hubs/messages, and this is my chat. Now my chat is going to do a lot of different things. It's going to handle being able to send, subscribing a user to a group. It's also going to be able to send and receive messages from that group, and also signal when someone has left the group. So there's a lot that it can do, because you want to get notified when someone leaves and enters, so you can show that in the UI. So inside my hub chat, I have a few different methods. And it's going to look very, very similar to what we just saw, but instead of having this iHub context, I'm inside the hub, so I immediately have access to everything inside the hub, like groups, the clients that are inside of there. So if I look here, and if the first thing I want to do is tap on a group, a chat room, I'm going to add myself to the group. Now this user that I'm passing in is just a username that I specified. So James or Heather or Maddie, for instance. It's kind of my unique identifier for me in the UI. But when I add this, this will be called from the mobile app. It'll pass in the group. And what we'll see is that I'm using context.connection ID. Remember when I said that SignalR will automatically generate a unique user ID on every connection? That's what that is. So if every single one of you here calls add to group, it's going to generate a unique ID for every single one of you, every connection, which is cool. You don't have to worry about it. Now what's nice of this is I'm saying groups, just internally, it manages that group for me. So I add this user with that connection ID to the group. And then what I do here is I say clients in group with group name send a message that this user has entered. So now if a bunch of people are in the room, they'll get a notification when someone has added themselves to the group. Similarly, exactly the same from remove from group. Same information, except for I say remove from group async, and then I send a message that they've left. Then honestly, besides that, all I have to do is have another method that I can call from my mobile apps that's send message to a specific group. So notice here we're going to send in a bunch of different information. We're going to send the group name that I want to send to, the user name, for instance, that maybe I want to get some information because I need to broadcast that to everyone else, and then the message. Now I don't care about the connection IDs at this point. I don't have to maintain a list of connection IDs because SignalR in the backend knows that I've added and removed these specific connection IDs, and that's who I'm going to be sending messages to. So really the backend code, 30 lines of code, and I just wrote a chat application. Awesome. So let's look at the backend here. Again, I have an iOS and an Android app. And what I can do inside of here is create a chat room. So over here, what I'm going to do, is this where I'm at? Oh, no, I put it in here. Even better. The code is not even in my mobile app. It's in a different .NET Standard library because that's how we do it. So I was like, yeah, man, where's my code at? I made it so abstracted, and how SignalR for .NET can work is it can work with every single .NET application. And that's why I thought that every good chat application needed a great mobile client and a console application. So I wrote a great program, .cs. It's terrible. It's really bad code. Don't write this code. But I wrote this code because I wanted to test it locally. So what I have here is a console app and my mobile apps, and they're sharing the same .NET Standard library that will send and receive messages from SignalR, because it can be used in any .NET app. So what I've done here is I've specified basically just some events that will occur. So any mobile app, any other application subscribe to events instead of subscribing directly to SignalR. So I have some message event arguments. The arguments here pass in a message and a user, basically. And my chat service is kind of similar to what I had previously, except for any of my clients can register for an on-received message, on entered or exited, and on connection close, so different events. And then I've isolated this code into the single chat service. So I have a hub connection. I have an initialize here. And what this does is it will detect basically IP addresses I need to use if it's HTTPS or not. Else it'll just use whatever URL I pass in. I'm going to use that very similar code. Hub connection builder, do it with the URL, whatever I'm creating. Of course, here I'm doing the IP, port, hub, chat, the same URL. And what's cool is that we did have, for instance, that hub on, but there's also on closed. So for instance, if my mobile apps, if I lose connectivity and I come back up, I want to make sure if I've disconnected from the service, I reconnect. So here what I can do is I can simply come in and wait a few seconds and disconnect, and I could give up after so long, for instance. Here, I'm just trying forever because it's demo. That's not best practice. Don't do that. Or maybe do that. It's your app. It's, live your life. It's OK to be yourself. I'm not going to tell you what to do. And that's it. So now what I do is I simplify these messages down into these connections, which is exactly what we saw before. Receive message, entered, left. And now what I do is I pass messages back to my mobile app that they can subscribe to. And that way, this is what you want to display in your UI. This message, this user entered, this user exited. I kind of just really simplified it. The other code that's inside of here is some connection code. So again, connect async, make sure I'm not connected, start, disconnect, disconnect, and I just dispose asynchronously. So when I've left, I dispose asynchronously, get rid of everything. And then I have a few methods to send messages to the hub. Remember before we were saying on? Well, it's the same exact code, or very similar code, to what we sent from our backend code earlier. Here, whenever I want to join a channel, I'm going to send a message, add to group with the group and the username. When I leave it, I'm going to notify SignalR that I want to remove myself from the group, and boom, I've sent those messages up. SignalR receives it and sends another message out. And then in the back end here, I have a way to send a message. So again, it's really just sending messages back and forth. In this instance, I can do send async, which does not await a response from the server. On invoke async, this one does wait for a response from the server. So when I send a message, I really want to make sure that it was sent. And then I have a little get rooms. Now, I could have added this into my backend, but I just hard-coded it in here, and these are the rooms that I want to use. So what I'm going to do now is we're going to go ahead and spin up this backend service. Did you know that you can do that? You can type in CMD. Did everybody know that besides me up until like 3 weeks ago? Because when you do that, it opens the command prompt right there. It's amazing. Yeah, I didn't know that either. It's bananas. So there we go. So I'm going to run my backend. Yeah, it blew my mind. I was like, what? Because you know what I would do is I'd be like CMD, copy, CD, like blah. There we go. OK, so here it is. It's running locally on my port. It's just sitting here. And then what we're going to do is we're going to run our mobile app. So here's our chat room over here. And if I go into the chat view model, what we can see is that I have a few different properties inside of here, some commands, so the UI can interact. Send a message, connect, disconnect. And this is standard Xamarin stuff. So inside of here, I have an observable collection of chat messages, of users, and I just start subscribing to events. And I don't unregister because I didn't go to Shane's session. So I'm just registering, and who cares? Just live your life. So I register, and then I'm just basically adding, removing user interface from here. So whenever I go in and I send a message, I make sure that it's on the UI thread. I make sure that this user exists, and then I insert it. Whenever I remove the user, I remove that user or add the user from the list. And the same thing here for sending a message. Whenever I type send, I send the message with the username. So here I have my mobile app. Over here, we'll make this a little bit bigger. Let's make this a little bit bigger here. Boop. And in my profile, I'm using Xamarin Essentials just to save this local IP address and my username so I can use it everywhere. So this is localhost. What I'm going to do is just go into the Xamarin group. And there was an error that occurred. That's good. Well, I can see that nothing is happening here. That's good. An error occurred. Well, let's debug it. When in doubt, debug it live. OK. And also, when you debug, you can just have a little jingle like that, and then, my assumption here, which, this is running correctly. HTTP. Yes. Let me just make sure that I did this, because it worked 10 minutes ago. Local host, yes. Oh, okay. And what we'll do is let's just make sure that in my chat service I'm connecting on the right URL. Okay? And we'll put this here. There we go. Let's connect to the Xamarin chat room. My URL is localhost HTTP. Yeah, that looks correct. No, that is not correct. It is not correct because the IP for Android, like we all remembered earlier, was 10.0.2.2. Classic James. Perfect. All right, so let's do this. So we're going to do 10.0.2.2. Is that it? Yes. Yes. All right. Perfect. And we're connected. Whew! We did it, yeah. But I have no friends to communicate with. Well, luckily, I have a console application that can communicate. Wouldn't that be great? So what I can do here is cmd that, boom, .NET run. Check this out. Awesome. Look at this. Enter, you mean this is, how do I make that bigger? I don't even know how to make it bigger. Control? No. Alt? No, I don't know. Localhost. Now this is localhost. Connected. Do it. Yes. Now I get my rooms. Oh, here we go. Let's put this over here. Wow. I guess I'll put this over here. That's better. I'll zoom in, because I love to zoom. Everyone knows me. I love to zoom. Xamarin. Oh, I'm in the room. Leave. I'm no longer in the room. I'm in the room? No longer in the room. I don't want to be your friend. All right, now I'm in the room. Now check this out. To prove it to you, .NET. I'm in the .NET room. Leave. Back in the Xamarin room. Because I'm in a group. Hi. Whoa, it works. Awesome. Now. But what's cool here is I can now not run it locally, and I could maybe publish this up into Azure. So what I've done ahead of time is I have published this just to an app service. It's running. It's an ASP.NET Core application running up inside of there. And what I've done over here is I've got into my configuration, and the only thing I have to do is enable WebSockets. That's basically it. Now this will be running on HTTPS, which is nice, automatically for me. So localhost, I'm just running HTTP. I'll run it up on HTTPS. So what I can do here is I could come out of here, and if I go into my log, I'll see that the website is zamchatter.azurewebsites.net. So here, I'm going to say zamchatter.azurewebsites.net. Go over here. I'm going to go into this room where I have connected into the back end. Boom. Oh, sad. Well, it's because it's on localhost, right? Now what we're going to do is we're going to look at my beautiful code, exit. Perfect. Exit. Right? And then we're going to .NET run. Of course it's exit. Why wouldn't I put it exit? Too hard to control C. So I'm going to say zamchatter.azurewebsites.net. And now my console is going to connect up in the Xamarin room. Boom. Awesome. Amazing. And then what I'm going to do is I'm going to go onto my mobile phones that are also on conference Wi-Fi, where I've installed the application here. And what we're going to do is not install an update for Hobby app. That would be bad. Let's install this. Let's go to Zam Chat. I'm there. Hi. And this is how I do this in real life. And then I come in here, and I have the app here, and I'm like, whoa. Whoa. There we go. And this is how people send text messages across every single one of their devices. And boom, I've just created a real-time chat communication app right there. Boom. Awesome. I have 5 minutes. 6 minutes. Let's talk about a different way of hosting our SignalR client. Because maybe you don't have an ASP.NET website. Well, we have something called Azure SignalR Service. What's great here is obviously with SignalR for ASP.NET, you can self-host that, put it anywhere, any cloud. But what happens when you really, really want to scale? What happens when it's not just me and my 18 test devices talking to each other? What happens when I create the best next chat application that's going to take the world by storm and tens of thousands of users use it? And what happens when I need 100,000 concurrent connections? That's where Azure SignalR comes in. Because you can only scale out an ASP.NET Core website so much with the SignalR. You also don't want to bog down your website. So Azure comes in and it'll handle everything for you. And what it does is it kind of sits in between you and your app server to handle all of the connections, everything possible that you want for you, up to tens of hundreds of thousands of concurrent connections. So it's that gateway in between. Now what I love about this, though, is that what we can build for it are Azure Functions. Azure Functions will be our gateway instead of the existing ASP.NET Core backend, and it will handle all of the communication back and forth. I can then use anything that Azure Functions uses, such as PowerShell scripts, all TypeScript, JavaScript, C#, Java, all the things, publish it to Azure SignalR Service, and then any of the clients can connect to it. It's really super simple, and it scales out on demand. So you literally go into the Azure portal, say SignalR Service, fill in a few informational things, select free, because everybody loves free. Wow, that's a cool animation. And then you're going to obviously select a service mode that we call serverless. So I have one more demo in the last 3 minutes I'll show off, which is how we can use Azure SignalR Service combined with Xamarin, the .NET SDK, and Azure Functions to create a real-time translation application from my browser to my mobile apps, scaling this out. So what it will do is in the browser, I have a Vue.js application that I did not write because I have no idea how Vue.js works. So my good friend Anthony Chu wrote that end of it. It's going to, in the browser, take in my microphone that I'm speaking in, translate it using Azure Translation Services, publish those translations to Azure Functions, which will then send those to Azure SignalR Service that will send out all of the translations to anyone that's listening. So let me show you what this looks like. Over here, I have a Vue.js application. It's a bunch of crazy JavaScript stuff. But what I want to show you is what's really kind of cool about it is that I'm using a translator API here, and I have just a simple way of posting these to my backend. So my Vue.js app doesn't really know anything about Azure SignalR for broadcasting. It's just going to use the translator service from JavaScript, bring it in, and handle it for me. I also have a way here of using the SignalR client to receive messages in JavaScript. So here I can post, I can get the list of languages. And then here, it's very similar. I'm going to create a hub client, build, just JavaScript. Then what I'm going to do is stop debugging, boop. And I'm going to go over here into my CaptionR service. And I have an Azure function that's sitting here. And what this does is it first starts out a way of negotiating and sort of registering. Our ASP.NET Hub handled that before. So I create a simple SignalR connection to negotiate. And that's what my clients are going to communicate with. What's cool then is that I have different RESTful endpoints that I can basically get a list of languages that the service supports. I can then also come in and select a language. And what this does is with Azure Functions, it can say SignalR, use hub name captions, and I can then send and receive information to that group automatically. So here's what I'm doing is I'm saying for this group, add the user that's passed in here with a group name, which is the language, and a specific action to add or remove them. And then whenever someone posts new languages, translations to it, I add those in here, And what I end up doing here is I loop through all of the languages that I've received, and then I send a SignalR message with the new captions out to the clients. And then literally, inside of my mobile app, what I'm going to do here is something that I did previously. I have a hub connection. I come in. I have, that's an HTTP client. I create a new hub builder. I have a new caption. And whenever I get a new caption, I display it. So here's what we're going to do, is I'm going to come over, and I've created the browser over here. I have one on each side. So this is what it sort of looks like. I'm going to start a session over here, and I'm going to start talking into it. Now, this isn't doing anything magical. This is just whatever I'm speaking is putting out stuff over here. And then I have a session that's going to connect to it for CaptionR. It's going to call into my Azure function and get a list of languages. And it's going to start outputting this information basically in real time. And then what I can do is I can say, oh, I would really like that in Japanese, and it's going to translate it into Japanese. And then what I can do is I can come over into my mobile application, which is now speaking to that same Azure backend and SignalR client, and I'm going to say get languages, and now my mobile app is speaking back. And now what you can do on your device, everybody take out their device right now in real time, and what you're going to do is you're going to go to this URL, aka.ms/xds-captioner, right there. I'll leave that up. And as I continue to speak, I'm just going to go in, I'm just going to go over to Korea, for instance, and just start doing this. And what you're going to do on your phone is you're going to see that same exact website, and everyone inside of here should be getting captions in real time of everything that I'm saying into this. And I'm literally just talking nonstop, so the translations continue to come up. And now what we've done is we've now made hundreds of real-time connections to the Azure SignalR client back end, connected from mobile apps, from web clients, all using those different graceful ways. And I hope it works, because I don't know what any of you are seeing right now, and no one's saying anything, and that's awkward. So I hope it works. Yes, did it work? Yeah, awesome. You can get all of this source code as well. So what have we learned now that I'm 2 minutes over? SignalR is awesome. Thank you so much. I'll be around for questions outside as well.